Model training in ML workflow. Model training in ML workflow. AI beginner level. Introduction. After preparing and engineering features from data, the next step in the machine learning workflow is model training. Model training is the stage where a machine learning algorithm learns patterns from data. During this process, the model studies input features and the correct output values in order to make accurate predictions. Model training is the core learning phase of machine learning. This step is used in many AI applications such as image recognition, speech recognition, recommendation systems, fraud detection, medical diagnosis, spam filtering. Understanding model training helps beginners learn how machines actually learn from data. What is model training? Model training is the process where a machine learning algorithm learns patterns from training data in order to make predictions. In simple words, model training equals teaching a machine learning model using data. Example concept. Training data means learning algorithm means trained model. The trained model can then be used to make predictions on new data. Training data. Machine learning models learn using training data. Training data contains input features, X, target labels, Y. Example dataset. Hours studied exam score, 250, 570, 890. Example concept. Input features, X. Means model means predicted output. Y. The model learns the relationship between the inputs and outputs. How model training works. During training, the model tries to find patterns that connect input features with target outputs. Example concept. Features plus labels means learn relationship means prediction function. The algorithm adjusts internal parameters to reduce prediction errors. The goal is to create a function that can predict outputs for unseen data. Model parameters. Machine learning models contain internal variables called parameters. Parameters are values that the algorithm learns during training. Example. In linear regression, slope, intercept. Example concept. Training data means adjust parameters means improved predictions. The algorithm continuously updates parameters to improve performance. Loss function. To measure how well a model performs during training, we use a loss function. A loss function measures the difference between predicted values, actual values. Example concept. Predicted value minus actual value means loss. A lower loss value means the model is making better predictions. Common loss functions include mean squared error, MSE, cross-entropy loss, log loss, optimization. During training, the model tries to minimize the loss function. This is done using optimization algorithms. One common optimization method is gradient descent. Example concept. Initial model means calculate error means adjust parameters means reduce loss. The process repeats many times until the model learns the best parameters. Training iterations. Epochs. Training does not happen only once. The model typically passes through the dataset multiple times. Each full pass through the dataset is called an epoch. Example concept. Training data means model learning means repeated epochs. More epochs allow the model to learn patterns better. But too many epochs can cause overfitting. Batch training. Sometimes datasets are very large. Instead of training with the entire dataset at once, the data is divided into smaller batches. Common approaches include batch gradient descent, uses the entire dataset at once. Mini-batch gradient descent, uses small groups of data. Stochastic gradient descent, updates parameters using one example at a time. Example concept. Large dataset means smaller batches means faster training. Mini-batch training is widely used in deep learning. Training versus testing. Training data is used for learning. Testing data is used for evaluation. Example concept. Training set means learn patterns. Test set means measure performance. Separating these datasets ensures the model generalizes well. Underfitting versus overfitting. During training, models can face two common problems. Underfitting. The model is too simple and cannot learn patterns. Example concept. Too simple model means poor learning. Overfitting. The model memorizes training data instead of learning general patterns. Example concept. Too complex model means memorizes data. A good model balances learning and generalization. Model training pipeline. A simplified training pipeline looks like this. Prepared data. Down pointing arrow. Select algorithm. Down pointing arrow. Train model. Down pointing arrow. Calculate loss. Down pointing arrow. Update parameters. Down pointing arrow. Repeat until learning stabilizes. This process produces the trained machine learning model. Example Python code. Machine learning model training is often done using Python libraries. Example using scikit-learn. From sklearn. Linear_model import linear regression. Example training code. Model.fit. x_train. y_train. This command trains the model using the training dataset. Real-world applications. Model training powers many real-world AI systems. Healthcare. Training models to detect diseases from medical images. Finance. Training models for credit risk prediction. E-commerce. Training recommendation algorithms. Transportation. Training models for self-driving cars. Cybersecurity. Training models to detect suspicious activities. Concepts learned from model training. Understanding model training helps beginners learn. Checkmark how machines learn patterns from data. Checkmark how training data teaches the model. Checkmark how loss functions measure prediction errors. Checkmark how optimization improves model parameters. Checkmark how models learn through repeated iterations. Model training is the central learning step of machine learning systems. Simple definition. Model training. The process where a machine learning algorithm learns patterns from training data to make predictions. Final summary. Model training is the step in the ML workflow where a machine learning algorithm learns patterns from training data. During training, the model adjusts its internal parameters to reduce prediction errors using a loss function and optimization algorithms. The process is repeated through multiple epochs until the model learns useful patterns. Once trained, the model can make predictions on new unseen data. Understanding model training is essential for learning machine learning, artificial intelligence, and data science fundamentals.